This is signum of x plus 1 into x minus 4. So using the wavy curvy method or sign of quadratic expression, in the given interval 2 to 4, I am talking in between roots. In between 2 less than or equals x less than 4, x square minus 3x minus 4 will be less than 0. If the input is less than 0, signum will be minus 1. Understand that one? When x less than 0, signum of x is minus 1. When x square minus 3x minus 4 less than 0, signum of that thing will be minus 1. So I wrote minus 1 for all x belongs closed bracket 2 to 4 open bracket. At 4 what is happening? It is vanishing. If it is vanishing, the signum of x square minus 3x minus 4 will be 0 at x is equals to 4. I hope this is clear to everybody. Now we are drawing the graph. Is this clear to everybody? Now graph. Okay, enough space I have to draw the graph. So from minus 1 to plus 1, minus 1 not included, plus 1 also not included, that is y is equals to x square. Y is equals to x square is a upward parabola, vertex is at horizon. Oh no, minus 1. At minus 1 it is 0. No? At minus 1 it is 0. So what I'll do? I'll write here. This is minus 1 comma 0. Do you understand this? This is x is equals to 1. So next, what is happening? Let us use different color. From 1 less than or equals x less than 2, it is y is equals to 2x minus 1. Slope is positive. If I put x is equals to 1 in this, I get 2 minus 1 is 1. The starting point is 1 comma 1. So this is the point 1 comma 1 is straight line with positive slope. At 2, it will stop. So like if you want, when x is 2, this point is 1 comma 1. When x is 2, how much we are getting? This is 2 2s are 4. 4 minus 1 is 3. 2 comma 3. Right? So next, in between 2 to 4, what I get? Like I think I should multiply, listen to me carefully. For signum, I should multiply minus 1. That is minus 1 into x square minus 1. That is an upward parabola. Right? Roots are plus 1 and minus 1. Right? Maybe starting at 2. At 2, what is the value? At 2, if I substitute x is equals to 2. 4 minus 1, it is 3. So if that is 3 here, so I am starting from this point. It is upward parabola like that it reached 3 and then it will go. So to change it, to show it is parabola, I have drawn like a curve. Clear? This is x is equals to 4. In the interval, no roots. No. It is upward parabola only, no? That much you know, right? Upward parabola only, no? I have drawn. I don't want entire parabola, right? I want in that interval. So I am using the range. When x is 2, y value I got 3. If you want when x is 4, how much is y value? This is 4 comma 16 minus 1, 50. Right? So when x is 4, right? Signum is 0, 0 into the entire thing, I'll get 0. There is a jump over here. Now notice that number of discontinuous points very important. Get minus 1, close bracket minus 1 and close bracket 4. There is a jump at minus 1. Here, initially it is at 0 and it jumped it. That's why it is continuous at minus 1. Now, at 0 there is no jump. At 1 there is no jump, it is continuous. At 3 there is no jump. But at 4 there is a here. So how many discontinuous points? 2, right? So now 2 discontinuous points. Now differentiable points is ready. So what about differentiable points? Listen carefully. This is the line. If I add the line, maybe let us add the equations. This is y is equals to x square. This line over here, y is equals to 2x minus 1. This is y is equals to x square minus 1. Open bracket minus 1 to 4. No need to verify the derivative at minus 1 at 4. Right? So like at 0 there is no dark corner answer. There is no P. How to check it? Let us differentiate the 2x side. Left hand derivative at 1 it is 2. Right hand derivative is no problem. That means it is differentiable at 1. Understand what? Differentiable at 1. What about there is another term? This side I 2 will be the slope. You differentiate 2 only I get slightly. Now this side you will get 2x. Put x equals to 4. Now x equals to is not differentiable. Point now 4 is not required. 2 is continuous. 3 not differentiable. No. Minus 1 and 4 is not included now. So 2 is continuous. 1 not differentiable. Understand this one? Any doubt in this? Offline students? This is how I'll do. So now I can see for continuity, y is equals to g of x as breaks at minus 1 and 4. See, even though it seems like a cusp or corner, we need to verify, right? So that's we did know. Y is equals to g of x as cusp at x is equals to 2 here. So now P is discontinuous points. P is equals to 2. Huh? No. Let me see one more time. Q is no. Then Q is so then 2 times of P plus Q, 2 2s are 4 plus 1, 5 sounds correct. Understand? Don't judge the cusp or corner by just seeing it. Now, if you copied this, you can go for break. If you are having some doubt, I'll be here only. You clarify your doubts and go. I want you to back by 1740. Am I clear? You want, you can go for it. Some internet problem. One moment. There seems a small internet problem. Sorry. Well, do you understand? Can I scroll this one up? One more nice problem like this here. Then can I scroll up? Graph what I can go? Any doubts in this part? Right. Okay. Next problem. Online students, if you want, you take 10 minutes break. Class will restart by 17. I'll read. It is like when they are given a functional equation. Maybe if you want any, you will use first derivative. For that, we should replace it. First derivative. Listen. Where is attendance? Everybody signed in. Student signed. X by first of all, f dash x is limit h approaches 0, f of x plus h minus f of x divided by if plus 1 I replace y dot x f of x plus h minus f of x less than or equals modulus x plus h and by h on take limit h approaches 0. We get f dash. Replace x by modulus of limit h divided where even slightly instead of becomes modulus do that variable only f dash x zero function is constant f of 0 is 0 yes f of x equals to in physics which chapter is being going on? Have you started okay. Difference as he tell about the difference. Tomorrow I am going to take the class, man. That's why I don't remember. Because I only take them to take the faculty to take from the next lesson PM. Then the PM manager will to ask for now. And the last topic, yesterday look around going to sorry. So EM from EM. Right? You can do how much time you have this partition. You cannot say there is discontinuous and continuous. You need to find limited minus Hmm. Try this one then. So dear, try this one by taking. No, not that difficult. For seeing everything will be difficult only. Yes, until you fix pen on paper, everything. Especially in one part, the second one is greatest thing is a fractional part by one plus fractional part. Super. Who told that? Who can you explain? Super want to use want to, then what we can say? Numerator, denominator. In fraction, numerator and denominator fraction will be lying in between zero. Take a simple of that one is give a percentage. Remind to make the problem difficult. They make them put the box or fractional part or modulus. In this problem, they have to seems like you are here, but brain is somewhere else. Maybe not. Right, Gautaman, please don't make noise. Please close the door. We'll wait maybe few are yet to come. Today, attendance. So then Deepan Raj only. You got the answer to it. So Deep and Raj, they didn't give interval. So what we will take? They didn't mention before problem they have given -1 to 4 close, -1 to 4 open. What will be the interval in this? What will be the interval? -1 to, who is saying that? -1 to 2. Well done. They have given the function in that interval only, no? So I can take -1 to 2 there. Open bracket. Neither -1 nor 2 included in this. So discontinuous and differentiable points are M and N here. So what and all we have? Greatest integer, fractional part, modulus. So then we are starting. Any of your friend yet to come? There is one seat empty. One boy, where he went home, ran away. That's all right. Okay, then let us start this problem. So again, two parts. How much space I have? I don't have much space. Case 1. Let us consider -1 less than x less than 1 case. Whatever the input, there is some integer. So fractional part of x belongs to closed 0 to 1 open. 1 plus fractional part of x belongs to closed 1 to 2. If you observe in this, numerator is in between 0 and 1, denominator is greater than 1. Numerator is greater than the denominator. If numerator is greater than the denominator, equality never happens. There are no common value in the range. I can say 0 less than or equals fractional part of x by 1 plus fractional part of x will be less than 1. Now greatest integer of this function when the range is in between 0 to 1, I can write here do you understand this one? Any doubt in this one? So like remaining is not that difficult. By graphical transformation I'll put. It is 16x square minus 4. This is the function. Roots are plus minus 4x square minus 1. X square is 1 by 4 plus minus 1 by 2. Right. So then the remaining second part, case 2. Here. No, no. Just I taken one minus 1 out. I didn't change sign. This function, if I want to break, I need to break into three parts. -1 to -1 by 2. In that interval, you will get 16x square minus 4. -1 by 2 to +1 by 2, there 4 minus 16x square. 1 by 2 to 1, 16x square minus 4. Three parts. I will do the graphical transformation, I will get it. Clear? So now, in this case, what is the interval? 1 less than or equals x less than 2 here. So now x square minus 2x can be written as x square minus 2x plus 1 minus 1. So 0 less than or equals x minus 1 less than 1. Square, if we do 0 less than or equals x minus 1 whole square less than 1. Subtracting minus 1 less than or equals x minus 1 whole square minus 1 less than 0. There is one integer, so there is one point of doubt, right? So I can say the range x square minus 2x belongs to closed bracket minus 1 to 0 in for all x belongs. Okay, I think we can do directly here. If I take greatest integer for this, minus 1, well done. Right? So now we are drawing this. Maybe for graph this space, let us use, sorry, okay. Let us draw in between minus 1 and plus 1. 16x square minus 4. Actually, 16x square minus 4 is a upward parabola. This much big is it required? 16x square minus 4. This part is minus 1 by 2 comma 0. Below part is 1 by 2 comma 0. Next part. Modulus I take, identifying the below portion, erasing and flipping up. So we have clear. So this is minus 1 by 2 comma 0 plus 1 by 2 comma 0. So when x is 0, I think this will be 0 comma 4. So next, in the interval 1 to 2, it is minus 1. So 1 is included, 2 is not included. You want the equation. This curve is y is equals to 16x square minus 4. This is y is equals 4 minus 16x square. Y is equals 16x square minus 4. Y is equals minus 1. 1 comma minus 1. So now let us identify discontinuous points in the interval open bracket minus 1 to 2 open bracket. So like -1 is not there. Continuous, continuous, continuous. Break is at 1. Clear? So one discontinuous point. Non-differentiable. You want you check 1, 2, 3. Clear? So now m value is 1, n value is 3. 8 minus 3, 5 will be the answer. Understood? Sorry? What is the function f of x, g of x? G of x. One moment, let me change, then this must be g of x. Uh, y is equals to g of x as break at x equals to 1. Y is equals to g of x as plus or corner. X is equals to minus 1 by 2 and x is equals to 1 by 2. Number of discontinuous points m is equals to 1, that is at x is equals to 1. Number of non-differentiable points those points are n is equals to 3 at x is minus 1 by 2 plus 1 by 2 and 1. It is non-differentiable at 1 because discontinuous at 1. I hope this is clear. Any doubts? So anybody writing anything from here? Case 1 and case 2? Anybody writing anything from here? You can. Scrolling up. See, all problems can be solved using graph. If we cannot put graph, we need to break. Maybe breaking models till now we didn't use graph. Maybe tomorrow we'll put. To be honest, today no maths class. So anything can happen. As per schedule, 3 were there. Maybe some physics arrangement ready. That could have been reduced to 2 or 1. Not sure. 0 also don't know. Check the whale, any doubt? Okay. Okay, va? Just 2 minutes. Once they are done, we'll go to the next problem. So Sri Chris and his friends. What you guys are doing? Graph also done. No? So then, so I have thought enough models is what I am feeling now. You want try tell me how many discontinuous points are there. You want you can add different non-differentiable points as well. X belongs to in order to make this one interesting. I can put uh, real numbers. No, it is not on the interval. Oh, minus 3 pi to 3 pi r, whatever is r you give. I'll everybody done the conclusion part. So now let me ask what you are doing till now. Why? Take deep breath. Talk slowly. I won't read. Okay. That you can do it. Deep breath, Really, I won't read. Am I looking scary or what? See, sit down, sit down. To scare you, I tell some words and all. Actually, I won't do anything like that. Simply only I asked why late. Some reason is there. I won't say anything. Don't worry. Am I scaring you guys? Right. So then let us start with Gautama. Tell me how many discontinuous points are non-differentiable also you add here. Discontinuous and non-differentiable you find. Who will tell? What do you think about cos modulus of x? Do you think cos modulus of x is discontinuous at any point? Do you think cos modulus of x is non-differentiable at any point? We need to justify why no non-differentiable points. Cos is what function? Even function. Then cos mod x are cos of x both sides. Right? So that means it is just cos x. You want to add cos mod x is continuous and differentiable everywhere. To be honest, cos mod x is equals to cos x only. It is symmetric about x is equals to 0 line, y-axis. Already it is a mirror image. Even though you take same only you will get. Right? Then it is done. Second one, tell me, greatest integer of tan inverse x. By now, somebody would have got no online. Tarun Krish, how to break? What do you think? Tan inverse of x, what kind of function it is? Increasing, decreasing, neither increasing nor decreasing. Let's go to the graph. And let us differentiate. A function is said to be increasing, a differentiable function, if its first derivative is greater than can be equal at few points. First derivative of tan inverse x is 1 by 1 plus x square, always greater than 0, increasing function. That means no turning points. Then number of discontinuous points or non-differentiable points will be number of integers in the range of 3 tan inverse x. Oh, 3, sorry, 3 is not there, just tan inverse x. So what is range of tan inverse x? Minus infinity to plus infinity, yeah? Minus pi by 2 to, how much is minus pi by 2 approximately? Minus 1.57 to plus 1.57. How many integers are there in that? That many discontinuous points. What are those? That many discontinuous points. X is minus 1, correct? 3 discontinuous points means 3 non-differentiable points. Function f of x is discontinuous, but g of x is continuous, their sum must be discontinuous. Anything else? 3, no weakness. 3 integers are there, so 3 discontinuous points. What, like if we want that, you equate tan inverse x is equals to minus 1. X will be minus tan 1 point. Tan inverse x is equals to 0. X is 1, x is tan 1. 3 point. Y graph. Maybe. I don't think here graph is required. Understood? So I'm not writing anything here. First of all here, what is range of tan inverse x? Take white. Take white. any real number. Approximately how much is this one here? Greatest integer will be they can put cot inverse. If they want, they'll put sin inverse, cos inverse. Range only. Okay, like let's see. Note down one problem. Note down one problem. Function f of x is sin inverse of sin x. Function f of x is sin inverse of sin x. You want interval? Take minus pi to plus pi. Open bracket. Tell me discontinuous and non-differentiable point. Minus pi to plus pi. F of x is sin inverse of sin x. X belongs to open bracket minus pi to plus pi. Tell me about non-differentiable and discontinuous points if there are any. I am asking just how many. How many of you remember the graph of sin inverse of sin x? When you are done. How many corners are there in that? At minus pi by 2, at pi by 2. Where is the third one? Then how many non-differentiable points? 2. To make that one interesting, add f of x is equals sin inverse of modulus sin x. F of x is equals sin inverse of modulus sin x. Interval you take minus pi to plus pi, both are open. Tell me. Yeah, I don't know answer. I don't want answer as well. I want your approach. How you are thinking. See, I have asked two problems. Deepan Raj, what happened? So Tarun Krish will tell answer for this one. So dear Tarun Krish, how many non-differentiable points this function or how many discontinuous points this function have in that interval? See, like I made it very short interval. I can also make it big. You're understanding, right? That is it. Any doubts? If you have any doubt, just ask. Right? So like this one, do you understand? Two non-differentiable points are there. One is at x minus pi by 2, at x pi by 2. What about this one? Three points are, what are those three? Minus pi by 2, pi by 2, 0. Can you elaborate how actually you did that? Okay, uh, I think mod sin x will be okay, one is all fine. So then the graph seems the output must be positive all the time. Output must be positive means this is what I'm thinking, right? I hope you understood. Going to the next model. Which one? Like using this, the output of sine inverse of sin x will be. Hmm? No, no, actually the graph will be minus pi by 2 to plus pi by 2. The below part, right? Please stay quiet. When the functions are defined differently for rational and irrational, these functions are said to be continuous functions at finitely many points. We need to find those finitely many points. Let's say I am saying at x equals to a. Limit x approaches a, f of x I write. A plus a minus whatever it is. F of x I write. If a is rational, I'll get this one. Sin a. If a is irrational, I'll get cos a. For all values of a, sin a and cos a is not equal. So that means it has more discontinuous points than the continuous. Till now, whatever function we have learned, signum function only one discontinuous. Greatest integer function, integers alone, right? So now this function will be having less continuous points, more discontinuous points. Drawing this is not easy, as I said. If I write at x equals a, I want to check limit x approaches a, f of x can be sin a or cos a, depending on rational or irrational. Clear? Again, f of a can be sin a or cos a. If I take left hand limit and right hand limit into the equation, let us take a situation when x is rational. Can I say in the neighborhood of a, right neighborhood, everything is rational or everything is irrational? I cannot say, right? Same argument I can use. So most of the points, it is discontinuous. If we need the continuous points, just equate them. If we equate, we'll get the continuous points. Do you understand this argument? Any doubts in this? If I equate sin x and cos x, I have finitely many values in the interval. Tell that finitely many values. How many are there? Sin x is equals to cos x. Tan x is 1. That means pi by 4. Pi plus pi by 4. Then 2 pi plus pi by 4. 3 pi plus pi by 4. 3 up, 4 up, 4 up. Which one is fourth one? 3 pi is 9 point something plus pi by 4, right? So I think 3 will be the answer. Do you understand this argument? See, I have explained, now listen. To check continuity at A, 3 pi plus pi by 4 is not there, no? Can you check approximately how much is that? 10 point? Then it won't be there. Clear? When A is rational, actually if I'm taking two parts, right hand and left hand limit, in the neighborhood I cannot say anything. To say the function is continuous, the limit must be equal. The limit must be equal, na? Cos A must be equals sin A. That is what two possible values. That two possible values are equal, na? Then I can say if y is equals to f of x is continuous at x equals to a, then cos a must be equals to sin a. Tan a is 1. Tan a is 1 means a can be pi by 4. Pi plus pi by 4. 2 pi plus pi by 4. In this given interval, only 3 continuous points. Remaining all are discontinuous points. See, if we want any problem on this, we can take one small problem. F of x is equals to x when x belongs to rational, 1 minus x when x does not belongs to rational. Find the point where f of x is continuous. Then, so like only one point will be there, and right? Remaining all points are because limit does not. Limit value is different. Maybe let me zoom this problem. Can you see this one? This is another model. Function is itself defined on element. I need to calculate and I need to check the continuity of this function. Please note down. Will do. So now tell me how to do this. This is JEE mains PYQ. In mains they asked option they are talking about 1, -1 and 0. 3 points. So like this entire thing depending upon like if I substitute n as infinity, x power infinity is there. X power infinity can be 0. It can be infinity. It can be 1 as well in some situation. How to do actually this one? Let us say case 1. Everywhere x power 2n, x power 2n, x power 2n. So x square power n we write. Case 1 when x square is less than 1. When x square is less than 1, I can say as n approaching infinity, x power 2n will approach 0. Clear? So when in this case, right? So f of x will be equals to limit n approaches infinity cos 2 pi into x minus x to the power 2n sin x minus 1 divided by 1 plus x to the power 2n into x minus x to the power 2n. So using this argument, in x power 2n I can write 0. Do you understand? It is decreasing function. If it is decreasing function, at infinity, the function very close to x-axis, y equals 0. Now this becomes cos 2 pi into x minus 0 by 1 plus 0 and minus 0. Function f of x is cos 2 pi into x whenever minus 1 less than x less than 1. This one is clear. Next, second case. Please don't make any noise. X square is greater than 1. As n approaching infinity, x power 2n will approach infinity. A reciprocal of x power 2n will approach 0. So now f of x will be equals to limit n approaches infinity. I am taking x power 2n common. So cos 2 pi x divided by x power 2n minus sin x minus 1 divided by 1 by x power 2n plus x minus 1. So now if I calculate the limit, it is 0 minus sin x minus 1 divided by 0 plus x minus 1. Now the function f of x is equals to minus 1. Oh, no, not minus 1. Minus 1 into sin x minus 1 divided by x minus 1. It is minus 1 when x is approaching 1. So last case, when x square is equals to 1, it is not tending 1. Don't get confused. X square is equals to 1. F of x is equals to limit n is approaching infinity cos 2 pi into x, right? Minus 1 into x to the power 2n. When x square is 1, x square to the power 2n is also 1 sin x minus 1 divided by the denominator will be what? The denominator will get us 1 plus 1 minus 1. So this 2 will be, okay, one more. 1 into x minus 1. I said x square only 1. So plus 1 minus 1 got cancelled. So this becomes f of x is cos 2 pi into x minus sin x minus 1 divided by 1. F of 1 and f of minus 1 need to be calculated here. F of 1 will be equals to cos 2 pi. Cos 2 pi is 1, 1. 1 minus sin 0 is 0 by 1. Similarly, f of minus 1 cos minus 2 pi is 1 minus sin minus 2 divided by minus 1. Minus 1 into 1 plus sin 2. I hope this is clear. Now the function f of x in partwise. Where do we go? Minus 1 into sin x minus 1 divided by x minus 1. X less than minus 1. Minus 1 minus sin 2 when x equals minus 1 less than x less than 1. In that case, cos 2 pi x is equals to 1, it will be 1. X greater than 1, minus 1 sin x minus 1 divided by x minus 1. Continuity need to be verified. Point of doubt is minus 1 and plus 1. Right? So at minus 1, left hand limit will be put minus 1 here, sin of minus 2 divided by minus 2. So that is minus 1 by 2 into sin 2. Both denominator numerator, that is minus. What we utilize. That is not equals. Right? So discontinuous at minus 1. At 1. How much is this? Cos 2 pi is 1. This one, as x is approaching 1. This one will approach where? As x approaching 1, limit x approaching 1, minus 1 into sin x minus 1 by x minus 1. How much I get? Minus 1. So again at 1 also, that is discontinuous. Understood? Any doubt? So the small conclusion part you can add here. Do you understand? There are two discontinuous points that I have concluded by checking left hand and right hand limit at minus 1 and plus 1. My job is done once I gave this. Hereafter you should only check. So now let me give you some homework problems. Go home and try once. Problem 62. Problem 62. Problem 67. Let me know if we solved anything earlier. 62, 67, 68. We did earlier. 68 we did. Remaining two we didn't do, right? 62, 67. Then 69. 73. Try, these are all good problems. One more model is there that I need to discuss in class. Let us discuss that problem as well. That is page number 56, problem number 30. Page number 56, problem number 30. If tomorrow any class is given, we are not solving any problems from continuity and differentiability. What we do there is we will finish methods of derivatives, differentiation. Then some theorems are there, mean value theorems, and their application. So problem 30, page number 56. Function f is given, function g is given. Function f is 1 by x minus 1 into x minus 2. So x not equals to 1 and 2. Function g is given 1 by x square, x not equals to 0. Before solving this, let me recall, if there is any point is not there in the domain, for example tan x, pi by 2. At pi by 2, tan will be discontinuous. So now we need to tell about discontinuous points of f of g of x. So this will be 1 by 1 by x square minus 1 into 1 by x square minus 2. So we get x to the power 4 by 1 minus x square 1 minus 2x square. So I can say x not equals to plus minus 1, x not equals to plus minus 1 by root 2. If I remove these 4 points, including x not equals to 0, because in the domain of f of g, 0 won't be there, domain will be domain of g only. 0 is not there. G of 0 is not defined. That means f of g of 0 is not defined. Function will be discontinuous at 0. Clear? Now, plus 1 minus 1, denominator 0, plus minus 1 by root 2, denominator 0. So total 0, 1, 2, 3, 4, 5 points are there. Do you understand? See, like what some student thinks, 0 they won't count and they will say only 4 discontinuous points. 0 we need to count because in the domain of f of z, 0 is not there, and then these 4 should not be there. Understand? Remaining y continuous, rational. Rational continuous in the domain. So if somebody asks you, my dear students, what kind of discontinuity this function have at these points, what you will say? Can anybody name the type of discontinuity the function f g, f composition g at 0, 1, minus 1, 1 by root 2 and minus 1 by root 2? Removable. Can you recall what is removable discontinuity? When we will redefine, first limit should exist, no? What do you think? Limit exists, huh? Maybe at 0, limit might exist. 0, it is 0. So at 0, it is missing point discontinuity. 0 is not there in the domain. At 1, minus 1, 1 by root 2 and minus 1 by root 2. At this point, this function approaching. So that is infinite type discontinuity. We cannot remove them. Understand? Next, another problem I have seen, which I felt I need to discuss in class. A few models are there and PYQs that we will discuss in tomorrow's class. I think it is 8:30. If you have any doubts, you can wait, or else we'll see again tomorrow. Thank you for attending. Online students, please wait.
Thank you, sir.
Attendance, please, attendance. Attendance, these guys went. Please wait just a moment. I call quickly the names and I'll mark the attendance. Akshay Krishna M, Abhishek Priyan R, Desna. Ishan, my number, Gayatri V online. Please, one moment, please. I'm seeing like unmarked alone. I'll put remaining. I'll take care. Krishna seems online. Ramakrishnan, Samantha, Sarvesh Kumar, Kumar, Pratiksha. Okay, you guys can go. I'll manage attendance.
Thank you, sir.
Thank you, dear.
Thank you, sir.
Thank you, dear. Thank you. Thank you, dear. Thank you, dear. Thank you, dear. Thank you, dear. I want to talk with Tarun Krish. Remaining all can go.